Okay, first things first. It says graph on your calculator right now, guys. Would you graph that function, the quantity x minus 2 squared times the quantity x plus 1 cubed? Graph it, take a look at it, and let's talk about it, okay? What it was. Okay, what's the second quantity, guys? X what?
X plus 1.
X plus 1?
Cube.
Okay. Are you sure?
Yeah.
Okay.
X minus 2.
All right. X minus 2 squared, x plus 1. Okay. Guys, because I lost a little bit of time there, I'm just going to get going. Can I just take a peek at, let's say, yours? Okay, it kind of looks like this, doesn't it? Like that. This, right? Is that about what it looks like? Yeah. Okay. Here's the deal. We're going to talk about multiplicities, and multiplicities mean you're going to repeat a zero. So if I were to do this, I'd ask you this: what's your zero? In this one, it's x equals what? 2. In this one, it's what? X equals -1. Okay, so there are your zeros, which means it crosses the x-axis at 2 right here and -1 right here. Okay, but here's the deal: this factor up here happened how many times? Twice. It's really this, right? X minus 2 times x minus 2. This is what's known as multiplicity. Okay, so the 2 has a multiplicity of 2, right? But when you look at -1 has a multiplicity of what? 3. Okay? All right. So here's the deal. When you look at your graph, you kind of have to say to yourself, okay, if you have multiplicity 2, what does it do at that 0, the graph? It bounces, right. So even multiplicity will bounce, okay? But here's the deal. Remember yesterday when I had you graph x squared, x to the 4th, x to the 6th? The bigger the multiplicity, if it's even, 2, 4, 6, 8, the bounce happens every time, but the bounce is a little slower as the multiplicity gets bigger. A multiplicity of 4 would bounce a little slower. Multiplicity of 6 bounces, but really slow, okay? Now, when it comes to odd multiplicity, 3, notice what happened here. Multiplicity of 3, it does cross the x-axis, but it didn't just go right through it. It kind of swayed a little slower, and then it took off. So the slower it goes through, the higher the multiplicity. So this one is multiplicity of what? 3. Multiplicity of 1 would look like what?
A line.
Okay, multiplicity of 1 means it's coming like this, and it's going to do what? Yeah, it pretty much just crosses. There's no like hesitation. It doesn't ride the x-axis, it goes right across. Okay, and the higher the multiplicity, the slower it will cross. So this would be 3, but this might be what?
6.
Well, that's not odd. 5 or 7 or something like that, okay? Odd multiplicity crosses the x-axis. Even multiplicity bounces, and of course the higher the power, the slower it bounces or the slower it goes through. Okay? All right. Here's the rest of this. And I know you guys can already read yours, but let's just read it again. It says if a factor is repeated, and here's repeating right here. We are repeating with these exponents, okay? As in x minus a to the k power. Then the 0 has a multiplicity of what? Okay. So you have a multiplicity of 2 or 3 or 4 or 5 or 6, whatever it says. Okay? And the graph is affected by, now, here we go. If k is even, the graph touches the x-axis, but does not cross it at a. Doesn't cross, it bounces. Okay? If k is what? Odd, the graph crosses the x-axis at what? X equals a. It crosses, but the higher the multiplicity, it crosses slowly and down, okay? Or slowly and, all right? Oh, and then there's another note down here. Note, as k increases, gets larger and larger, the graph flattens out as it intersects the x-axis. And you might want to do this. Maybe go like this, okay? That's a multiplicity of what? 1. This is a multiplicity of maybe 3, right? This is a multiplicity of maybe what? 5. Okay. Hey guys, you're kind of guessing. You're kind of guessing with 5 and 7. Most of the time, if I see a little sway like that, I go with this. Okay? You are guessing. And if you say even, you might want to write this word down. If k is even, it does not cross at x, but it what?
Bounces.
Yeah. Maybe write that to yourself. It bounces, okay? Okay, now I'm going to go backwards 2 slides. Did we do it at all? No. Okay. So here's what it is. Just simply this. Write an equation. Or let's say, not equation, let's say what? A function, okay. For this polynomial. Okay, here we go. I'm going to call it P of x, P for polynomial, okay? First, look at it and say end behavior. What's it doing on the end? Up. So we got an up, followed by an up. Okay, so that would mean the leading coefficient is positive or negative? No. Positive or negative. If it's up, it's what? Positive. Okay, good. Now, these factors, all factors come from zeros, right? Well, what are the zeros here? Let's make it easy, guys. 1. What's this one? Negative half. Okay, this is going by halves. So negative half. This one. Negative 2. This one. 3.5. Okay, so you have to realize zeros only come because they came from factors. So now we're going to take the zeros and stick them back into the factor. Here we go. It's always going to be x minus the 0. X minus negative 3.5. Plus 3.5, okay. Followed by x plus 2. Followed by x plus a half. Followed by x minus 1. Okay? And behavior was positive because it went up. All the zeros went into factors. Now count the multiplicity. Look at the graph. It went through. That's odd multiplicity. Are you going to call that a 1 or a 2? Or sorry, 1 or a 3 or a 5? That went through fast. It's a 1. Okay, this one. 1. This one. 1. This one. Okay, there it is. Anybody know what degree polynomial this is? Okay, it's quartic. All you got to do is add the what?
Multiplicity.
Just add your multiplicities. 1 plus 1 plus 1 plus 1. Positive, right? It's positive x to the 4th, which means it goes up, Even polynomials go up, up, or down, down. Because this went up, up, we know it's positive. I could make you FOIL that out, but that would just take you forever. And you'd have just a long, long polynomial. This is good enough. You have to write the equations or functions that fit the polynomial. They'll probably give you a picture in your book. Write the equation. Do it again. Try it again. This one's different. Now look at it close. Start with your end behavior, guys. Give me an equation.
Yeah.
All right. Okay, a lot of people have something on paper, which is good. Whether it's right or wrong, I don't know. Okay, what's this zero? -1, this one, this one, this one. Okay, look at your end behavior. Down on the left, up on the right, so it looks like this. It looks like a line going this way. Is that positive or is that negative?
Positive.
Okay, so your A value is positive, okay? Now look at your zeros. Your zeros create factors. This one would be x minus -1. Plus 1. This one is x minus 0. But,
Just do it.
Just X.
yeah, couldn't you just say x? Yeah. Okay, I'll leave it for now. This one's x what?
-1.
This one's what?
X
-3. Okay, last but not least, count the multiplicity. Look what happened. Here it comes.
Bounce.
It's a pretty quick bounce, isn't it? What are you going to call it?
Squared.
Squared. Okay, keep going. This one went
1,
through it pretty quick. It's a 1. This one turns the corner, goes through quick.
1,
It's a 1. And this one
3,
goes through it slower.
3.
Call it a 3. Okay. And there you go. Now, do you guys know what polynomial this is? Is it x? Is this an x squared polynomial? Is it x to the 5th? X to the 7th. Okay. So you guys say it's x to the 7th because you counted 2 plus 1 plus 1 plus 3 and got 7. Okay. And does x to the 7th, is that going to act like a line? Does an odd act like a line? Yeah. And being that it's positive, we know it's this way, and that's what it is. Okay. Questions? Nothing out there, huh? You guys, this is just really easy. Right? Nobody wants to ask a question. Okay, this is actually day 2. Okay, so let's go. Here's an example. Please write a polynomial function. So write yourself a polynomial function, p of x equals, which has zeros at -3 and -1, but has a multiplicity of 1 here and a multiplicity of 2 there. Go. This doesn't take long. Just see what you get. Did you get something wrong?
I didn't, well, I did get
Okay. Davidson, what is it then?
X minus 3,
X minus 3.
close parentheses, and then parentheses, x plus 1, 1 squared.
Squared? Yeah? Okay, do I know if it's positive or negative up front?
You do not know.
I don't know. They didn't tell me anything about the leading coefficient. If they would have said something like write a polynomial function that goes what? Up on the left.
Down on the right.
Okay, and they just stop right there. Do you know what it is?
Negative.
You think it's negative?
Yeah.
Because if it goes up on the left, do you know what kind of polynomial this is?
Cubic.
This is cubic because it's 1 plus 2, it's cubic, and cubic act like lines, so on the right it would have to do what? Go down. A line that goes down, the leading coefficient would be negative. But they didn't say this, and because they didn't say this, I have no idea. I have no idea what this leading coefficient is, so I'm just going to leave it. Okay, all right, good. Move on. Move on. You guys aren't saying anything. All right. In your assignment today, you will be asked to sketch the graph of the polynomial function. So we are just making a sketch. Is a sketch perfect? No, but it's going to be close, okay? Here's an example right here. Sketch the graph of this one. I'm going to write it a little larger for you. Okay? So to start the sketch, follow these 3 steps, and you should be fine on the test, on a quiz. Step 1. Apply the leading coefficient test and behavior.
Negative.
But that's not the end behavior. What's the end?
It's gonna be down, down.
Down, down. It's this way.
Up.
Up, up. It's this way.
It's down, down.
It is down, down.
It's down, down.
What are you supposed to be looking at?
The
The
biggest.
highest power. Guys, this is what you're looking at. Not the 2, highest power of x. And then you look and you go, oh wait, leading coefficient's what? Negative. You should say what?
Down, down.
Down, down. Okay? You know when you graph it, when you're done, it's going to look like something like this. Down here, down here. I'm just kind of getting a look. That's what I know it does in the end. Okay. Step 2, go find any what?
Zeros.
So what are the x values that make it 0 of the function? And then use the multiplicity of the zeros to help you know what it does at the x-axis. Does it go through? Does it bounce? You know? So, how do you get the zeros?
Factor.
What?
Factor.
But before you factor, I would always replace your what? Your f of x with what? 0. So here I go. I'll go up here. I'll replace it with 0 equals 5x squared minus x to the 4th. There you go.
Big square.
Go. Go get the zeros. And when you have them, point at them and I'll just say yes to your no. Yeah, you're good. Keep going. You got 2 factors here. What is this one? What is this one? You're so close. You're so close. All right, did you see it? GCF is what? X squared. Take it out. What's left? Okay, good. Look inside. Is that the difference of 2 perfect squares?
No.
Why not?
That's factor.
That 5 is not perfect. Oh, okay, we're done. Factor is done. So how many factors do you count up there?
3.
Factors are numbers you're multiplying. The first number you're multiplying is x squared. You're going to take x squared times what number? 5 minus x squared. So there's 2 factors. You have to tell me when is this factor times this factor going to be 0. Well, one of them has to be 0.
Square root 5.
So when is x squared equal to 0? Square root, X equals what?
0.
Okay, that's easy. The answer is, hey, 0 is a 0. You put 0 in, you get 0 out. Okay, there's another one. 5 minus x squared, when's it 0?
Plus or minus square root of 5.
Plus or minus square root of 5? Okay, okay. But hang on, let me show my work. You want to know when that number in there is 0? Set it equal to 0. Move the 5 over. Right? Now what?
Divide by negative.
Divide by negative 1, you get x squared equals, sorry, 5. Okay, now what? Square root, you get x equals what? Plus or minus square root of 5. Okay, so the zeros are square root of 5, negative square root of 5, and 0. Good?
Yeah.
Okay. Guys, when you get a factor that's unfactorable, how are you going to find the zeros? You solve it. Now, this was easy to solve, but when it's ugly, really ugly, let's say it was 5 minus 2x minus x squared, the only way for you to get the zeros is the quadratic formula. If it gets really ugly, nasty in there, you can't factor, the formula will always give you the answer. This one was doable. Okay, let's count the multiplicity. Okay? So guys, when you look at your factors, your first factor is simply x. But what's it raised to? Second power, which means the multiplicity for this 0 is 2. Okay? Now go look at your other factor. Your other factor is x minus x squared raised to the first. So the multiplicity in here is what? 1 and 1. This counts once, this counts once. And really the multiplicity is just telling you, does it go through the x-axis or does it bounce off the x-axis? So guys, let's plot the zeros. I know 0's here. Where's the square root of 5? Just after 2. It's actually 2.2. So Noah's right, just after 2 and just after negative 2. So there's the square root of 5, there's negative square root of 5, and there's 0. Now watch this. The end behavior, I'll take my pencil, I'll start writing it up. Okay, here we go. Now, I know it's going to hit square root of 5. What's it going to do though?
It's just going to go right through.
It's going to go right through. It's multiplicity 1. Okay, here it goes. Then it's going to come back and hit this one somehow. It hits 0. What's it going to do at 0? Multiplicity 2. Bounce. Okay. Up, turns the corner, comes back to this negative square root of 5. Multiplicity is 1. Boom, it goes through. Now, that's what it looks like, but you know what I don't know? I don't know how high it goes. I don't know how low it goes. Well, I do know forever. But how do I get the heights? Read that last one. Plot a few additional points. Oh, they want me to find some points. Okay. Well then, can't I just go, let's see, these x's between here and here, can't I just pick any one of them?
Go but halfway.
Well, you want me to go halfway between square root of 5 and 0.
Yeah. Split
Oh,
over
one.
2.
So that would be the square root of 5 divided by 2.
Yeah.
I don't want to.
Can you just do
Huh?
negative 1 on 1?
Okay, here's the deal, guys. Did you read the word? The word was what? Sketch. I know what you're saying. You want to get dead center and then get the height. I just want to make it easy on myself. I just want to pick a good number between 0 and square root of 5. I like 1 or 2. 2 is awfully close to square root of 5. I go with 1. Okay? So let's try 1. 1 goes in. Now I can't remember the function. Help me.
5x squared
5x squared what?
minus 6.
Okay, thank you. Okay, you guys, I want you to do the work here, so plug it in. You can work those out in your head. These are pretty easy. This would be 5. This would be what? Answer is 4. Okay? So what I know now is at 1, on the x-axis, I get 4 on the y-axis. So it's right here. Over 1 up. 4. I'm right here, look. There. That's what I know now. And it's going to bounce. Okay? Now you tell me what's a good number to try between 0 and negative square root of 5.
-1.
-1, yeah, why not? Put it in. -1 goes in. Okay, put a negative there, put a negative here. Kind of messy. Still going to be 5, isn't it? Because that's -1 times -1 times 5. This is still going to be what? 1. So it's still going to be 4 again. -1, 4. Put it on your papers. -1, 4 is here. So it goes like this, bounces up and through. Okay? Oh, that's wrong.
That's 3.
Sorry. Okay, a little higher. Let's go a little higher to 4. Good? Okay, but now here's the deal. How fast does this thing go down? Does it go like screaming down, or does it kind of widen out pretty quick? So you need to try one more number on the right of square root of 5, on the left of negative square root of 5. So you have to pick something a little bigger than this.
5.
3, 4, 5 probably, right?
5.
3, I'm hearing 3s and 4s and 5s. Okay. I personally wouldn't go to 5 because you're going to get awfully big. 3 is good. Put a 3 in, you get 5 times 3 to the second is 3 to the fourth. This is 9. 9 times 5 is 45. Minus 81,
Yeah.
I think. What's the answer?
-36.
-36, okay. There it is. Now, since you went to 3, just past the square root of 5, now go to the other side. Go to the other side of negative square root of 5. -3, okay. And I could just put a negative right here, right
The same.
here. And it ends up being exactly the same, doesn't it? Which tells me this polynomial is symmetrical. Do you think that happens a lot?
No.
No. Doesn't happen very often. It did here. Okay. So let's go up here. 3 gets you what? It's way down here, guys. I can't even do it. 3 gets you -36. -3 gets you same thing. -36. So this thing goes fast. It's going fast straight down. But does it get wider and wider?
Yeah.
It does. You can put in 10, you're going to get wider and wider. But when you put in 10, you're going to be down there somewhere around -5,000. You know what I mean? It's going pretty much vertical. It is bellying out. Do you feel okay sketching? Find your zeros, look at your multiplicity, then pick points between your zeros and outside your zeros. Just get yourself about 4 extra points, just so you can see the maximums and sometimes the minimums, okay? Questions? Okay. Now, this last problem, I think there's 3 left. I'm only going to do 2 of the 3. I think this problem, I kept thinking to myself, why am I even going over this? But really, it's good for you because you're going to use your table on your graphing calculator on this, and that's why I want to go over it, okay? All right, so if you read the problem, it says, if a driver was clocked going 60 miles per hour on mile marker 201, and 68 miles per hour at mile marker 202, so 60, then 68, he was going 65 miles per hour at some point during that mile. Why?
You had to pass a car.
He had to pass a car. Maybe there's no cars. No?
You have to go.
Speed limit change.
You would have
No, it's not saying why did he
in
go
order to
fast.
get from 60 to 68, you have
Okay,
to
hey, there's too many people talking. Noah, say it.
in order to get from 60 to 68, you'd have to go through all the numbers in between first.
So you eventually you have to hit every point, right?
Yeah.
You have to go 60.6, set 61.9. Eventually you have to hit 65. At one point in time, you are going 65. Then you're going to keep going faster, faster. But what this theorem says is if you're here at 60 miles an hour and then you're here at 68, at one point, you hit every one of those points all the way up. So yes, you were going 65. Now, the theorem is kind of weird, but I'll read it to you. The theorem says, let A and B be real numbers such that A is less than B. So what if A is less than B? You know what they just said? 60 is what?
Less than 60.
There you go. That's all they're saying. 60 is less than 68. If f is a polynomial function, then in the interval a to b means what? 60 to what? 68. That's what they're saying to you. In this interval, f takes on every value between f of 60 and f of 68.
Why do we need to know that?
I'm just telling you this. I'm just saying, I like this problem for your graphing calculator. Just be patient, okay? All right, ready? Move on. Here you go. Use the intermediate value theorem. How do we determine if this function right here, how do we determine if it has a what?
Has a 0.
In the interval. Oh, in this interval, 2 to 3. Now, when I say interval 2 to 3, where am I talking?
Between x is 2 and x is 3.
Okay, x. I'm talking x, yeah. 1, 2, 3. How would I know there is a 0 between 2 and 3?
Plug them both in.
Plug them both in, then what? Okay, watch. F of 2, f of 3. Watch this. Equals, I'm making this up, guys, 190. Is there a 0?
No.
Why not?
It doesn't. They're gonna
Big.
they're gonna positive.
One's positive, the other's positive.
Didn't cross.
It didn't cross the x-axis. One of them's got to be what?
Positive.
Positive. One of them's got to be what? Would you know now that this function takes on every value between here and here? Yeah, now there is a 0. Okay? So what I need you to do is go find the answer for f of 2. Go find the answer for f of 3. I was making these up, just so you know. F of 2 is what? F of 3 is what? Don't sit there. Do it. Anybody got f of 2?
2. Negative 2.
I got negative 2 and 2. Which one?
Negative.
Negative? Okay. So this one's negative 2, so which means right here. Right here. 2. There you go. You're right there. But f of 3 gave you 1. Okay. So f of 3 is 1. All right. Right there. So guys, this is a polynomial. I don't know what this polynomial does, but maybe it does something like this. Maybe it does that. I'm just making that up. But do I know there's a 0 now?
Yeah.
Yes. So because this is negative and this is positive, yes, comma, there is a 0. Okay? Now, how do I get closer and closer to that 0 without hitting my calculator, finding my 0? Watch this. If you take your calculator right now, guys, and if you do this, if you stick this equation in, is that the equation? Yeah? Okay, that's the equation. Stick it in. You need to do this. This is something you're going to learn and you're going to like this. I promise. You know there's a 0, right? Okay, if you went like this, second, table set. Guys, look what it is. Second table set. It's above window. You can tell your calculator, I want a table. And if I want the table to start at 2, I'll do it. And then this is the change in the table. I don't want to go by 0.1 quite yet. Let me go by just 1. I want my table to change by 1. So it goes 2, 3, 4, 5, 6, okay? Then if you hit second table, you get this table that kind of tells me at 2, the answer is negative 2. At 3, the answer is 1. So right about here, guys, can you see that there is a 0?
2 3/4.
No, but can you see?
Yeah.
This is negative 2 and positive 1. So there's a 0 here. So now I want to get closer. How do I get close?
0.1.
Change your table set to count by what?
0.1.
Let's go by 1/10. Go back to table setup and tell your table to start at 2, but count by what? How about just count by 0.1? Now watch. Table, and I'll go table, second graph. And now I can kind of tell where my 0 happens. All the answers are negative, 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 negative. What? Positive 0.24. My 0 happens between what? 2.7 and 2.8. So guys, what you want to do is this. Tell me at 2.7 and then tell me at 2.8. The answers are, I don't remember, I'm sorry. At 2 point, negative 1. Okay, and then what? 0.24. There you go. You know what you did? You just used your table feature to help you say the 0 happens, I'll say exists. The 0 exists between what? 2.7 and 2.8. 2.8. Okay, there it is. Now, if you wanted to get closer to the real 0, then you tell your table to count by what?
0.05.
You can go even smaller. 0.01. That'd be count by 1/100th. If you want to get smaller, count by 0.001. That'd be 1/1000.
So
So you can keep doing this forever and ever, and you'd eventually get it. But we all know this. Wouldn't it just be easier to hit what?
0.
Second, calculate, give me the 0. Okay. But you know what I like about that problem? It taught you how to use your table feature. So now you know how to use your table feature. Okay? Alright, how did yesterday go? Bad. Okay, a bad means show me a problem. What do you want? 30 what? 5. No, let's do 35. Come yesterday, 35. Okay. Other question? Anybody got their book open? You can just say 35.
F of x equals x squared minus 36.
Okay. X squared minus 36. F of x equals. Okay. Okay. And what am I doing to this problem?
Find all real zeros.
Okay, find the zeros. Okay, all the real zeros.
Determine the
Oh, give me the multiplicity. Gotcha. Multiplicity. And then what? Graph. Okay.
And the turning points.
And what?
And the turning points.
And how many turning points? Okay. Turning points. How many turns does it take? Okay. There are some things up here that are pretty easy. Turning points. See this too? This is a second degree polynomial. It will turn, take the degree, subtract 1. It will turn what? 1 time. You know why it's going to turn 1 time?
It's gonna bounce.
No, look at it. It's quadratic.
Yeah.
It's a what? It's a parabola. All parabolas turn once. Okay. All right, get some real zeros. Well, you want zeros? Let f of x equal 0. If you factor it, what do you get? Plus 6. That's minus 6, right? Okay. But the zeros are what? X equals 6. X equals what? Negative 6. What's the multiplicity on this one? And this one? Right here. 1. 1. There you go. The multiplicity is 1. Okay. Which, you know what that means to you? When it hits the x-axis, does it bounce or does it go through? Multiplicity
Goes
through it. Okay. All right, got it. Graph it. Okay, so to graph it, here we go. This is all I know. I know zeros are 6 and negative 6. Right here. Okay, I know the end behavior, don't I? Let's go back up. It's up. It's even. It's positive. I know it's up. Here's the cool thing. It's a parabola. Parabolas are symmetrical, guys. Where would the vertex happen?
On 0.
dead center, 0. So if you just let x be 0, I bet you can find the vertex quick. Yeah, 0 goes in. 2.36. Oh, that's why. 0, negative 36 down here. There you go. Hey guys, that's a quick sketch.
I'll make it.
What now?
I'll make it.
I think somebody told me.
I think he just says use your calculator.
Oh, just use your calculator?
Yeah.
Oh, well that, sorry. You could have used a calculator. I didn't hear that.
You don't need
What else? No, you shouldn't. Guys, listen. It's your time. You have questions?
This is 1-1.
2-1.
2-1.
Down to 2-1 I have right here. So yesterday you handed in 2-1. If you didn't, put it here. I'm going to look at it tonight. There are parent-teacher conferences. If there's a lull in time.
I'll look at
It used to be in here, but now it's up there, right there, top shelf. Top shelf right. Top shelf right. Go underneath. There's a bunch of it underneath. Okay, stuff that's turned the other way. 2-1 is here.
5.
Anything else? Put my pen down, you honest. Hey, don't wait until next week, Tuesday night after school, and you go, well, we're taking a quiz on Wednesday next week, I better come in for help now. Maybe tonight's a good night for help. Maybe tomorrow night, maybe Monday, maybe Tuesday. You call.
Something they did at home.
Now I gotta go
Design
again.
a kitchen.
I'll sign that. Okay, calm down. You don't need to go to do that.
See? Like if the chair.
Okay, can you guys meet me at the experience? It is bad. I just need you guys to be.
It's about signing a petition.
Oh. Why did you sign up a petition?
Because the cheer coach is mean. And so they want to fight.
The cheer coach is mean?
Yeah.
Because she wants you to cheer or somebody to cheer?
No, like to the student sections. That's why we signed it.
To the students?
Like during football games and stuff.
Who's the cheer coach?
She's new this year. I don't know her name.
Oh.
Can we go?
Yeah, it's only a minute early. Go ahead if you want.
Can I sign?
Janae has it.
She has it?
Yeah.
How does that work?
How's what work?
They're gonna take it to the school board or something.
Hey, you guys, if there have been people that have talked about the retake test, and I talked to you on Monday and Tuesday. I worked with you or Wednesday. It's time to take it. I know there's a couple in here that we got to get it tonight or tomorrow or something, right? So I'm looking around. And I know.
I'll be back.
You're coming back.
Take this.
Alright, we're gonna go over 3.
Tomorrow when your other friends.
I don't have brain cells. I guess I don't have future.
I'm gonna tell you this right after that.
That's what she told us.
She told Brian I didn't have brain cells.
I mean, yeah, but you can't say. Be there tomorrow.
She told us to shut up.
You're coming.
Because I was like reading her shoulder. I was like, we're doing the defense check. She's like, don't read it.
I'll do a Brad for doing that.
I was like, okay, so
Or next time, say, I'll go
hey, jump up there.
Yeah, you wanna know your score?
Hey, you guys need to call, hey, if it happens.
You already know what you got.
Hey, what? I read Trust me, she's like, you guys don't have to reach out. You did the victory chant. Hi. At least I can do it with my hand.
Like, the coach one time, like, we cheered through a day, and she did the, I feel great because we're on top, so it was 0-0.
Who's that game?
It's all season. Yeah.
Okay, so they won. You guys are on defense, right? And she chants the M-O-V-E.
So what happened? We don't want them to turn up to be on defense.
It's so much stuff. I know, this is a very short.
23, what happened was, I didn't like, I didn't think this went on. You guys did very well. But there were students that got all the time. So I said, I don't think I did a good enough job teaching this. So then I said, I knocked this off. And I did like 15. So, you 6 points.
Well, you.
When it comes to retaining,
I even forgot on that.
and you were here, so I can schedule. This is probably sitting. I bet you it's high. Maybe.
You want to come back here?
Yep. Well, you didn't get to look. You might have to school if you want.
How much water did you drink?
I mean, if you want to.
Not understanding.
Point.
Oh yeah, I saw that.
I didn't know, I thought we left at 2:15.
No.
You don't?
Oh, you are kidding me.